Location: Washington, D.C., early 1941. March 15th, 1941. Washington, D.C. The hum of war was already vibrating across the globe, and within the Pentagon, urgency hung thick in the air. The American military was desperate. The Axis powers had begun to gain ground, and the United States was drawn deeper into the global conflict. The Japanese had their sights on the Pacific, while the Germans continued their relentless advance across Europe. The world was on the brink of total chaos. The Navy, especially, was struggling with one major weakness. It could not see in the dark. The idea of radar technology, a game changer that had already begun to take root in other parts of the world, was still in its infancy for the United States. In the shadows of the bustling Pentagon, a civilian engineer named Albert J. Nimitz was about to change the course of naval warfare. An unassuming man, he had no military rank, but his brilliance in mechanical engineering would soon make him one of the most pivotal figures in the United States Navy. Nimitz had been working in the private sector as a systems engineer before the war, but when the U.S. Navy sought to bolster its radar capabilities, Nimitz's name would emerge as a solution. He was given a nearly impossible task: create a machine capable of assembling radar systems quickly and efficiently, making the U.S. Navy a true force to be reckoned with on the high seas. The stakes were high. The Japanese were already deploying radar systems aboard their warships, and the U.S. Navy was far behind. The need was urgent, and the window to catch up was closing rapidly. As Nimitz sat in his office, the weight of the task ahead of him felt like a boulder pressing against his chest. The military was counting on him, but the pressure only fueled his determination. It was late into the night when he first conceptualized the machine that would eventually be known as the Miracle Machine, a system that could streamline and accelerate the assembly of radar systems, cutting the time it took to build and install them from weeks to just days. If he succeeded, the Navy could deploy radar across their fleet at unprecedented speed, giving them an edge in battles that were still to come, most notably the brutal night battles in the Pacific. With limited resources, no formal military backing at first, and time running out, Nimitz began sketching the blueprints for what would soon be the Navy's greatest asset. Location: Philadelphia, Pennsylvania, summer 1941. June 1st, 1941, Philadelphia, Pennsylvania. The clanging of metal filled the air as the construction crews worked around the clock, building the foundations for Nimitz's invention. Albert J. Nimitz had moved his project to a small factory in Philadelphia, where a team of engineers and mechanics worked tirelessly to bring his vision to life. The goal was to create a machine that could build radar systems with speed and precision, but the challenge was monumental. The components of radar systems, the receivers, transmitters, and antennae, were complex, and they needed to be put together in a way that would guarantee reliability under the most strenuous conditions. Inside the factory, the smell of oil and grease filled the air as gears turned and machinery whirred to life. The workers, many of whom had no experience with radar, relied on Nimitz's guidance. He was their leader, their instructor, and their motivator. They had no time to waste. The U.S. Navy was depending on them to deliver a solution that could make the difference between victory and defeat. As Nimitz stood by the machine's prototype, watching it come together piece by piece, he knew the stakes had never been higher. If the machine worked, it would mean that the Navy could mass-produce radar systems faster than ever before. But if it failed, the consequences would be disastrous. The design of the Miracle Machine was a brilliant example of Nimitz's ingenuity. Rather than relying on human labor to assemble the complex radar components piece by piece, Nimitz devised a semi-automated process. The machine would combine precision engineering with assembly line speed. Each component would be precisely calibrated and fitted into place, ensuring that the final radar system was both functional and durable. What took weeks to assemble by hand could now be done in days. As Nimitz inspected the machine's first successful test run, a faint sense of pride swept over him. It was working, but there was no time to celebrate. The military needed results, and they needed them fast. Location: Pearl Harbor, Hawaii, November 1941. November 10th, 1941, Pearl Harbor, Hawaii. The sun was setting over the Pacific Ocean, casting a golden glow over the naval base at Pearl Harbor. In the distance, U.S. warships sat in the harbor, ready for anything. But the true power of the fleet was about to be revealed. The U.S. Navy had received its first shipment of radar systems assembled by the Miracle Machine, and the results were immediate. The radar systems were installed aboard several ships, including the USS Enterprise, a symbol of American strength in the Pacific. The USS Enterprise was preparing for a critical mission, one that would test the effectiveness of the radar in real combat conditions. It wasn't long before the ship's radar picked up its first contact, a Japanese fleet, approaching under the cover of darkness. For the first time in naval history, an American ship had the ability to detect enemy movements at night, and it was about to change the outcome of the battle. As the Japanese planes approached, the radar on the Enterprise gave the crew vital information, allowing them to prepare and intercept the incoming threat. The American pilots, flying under the cover of darkness, used the radar to pinpoint and destroy several enemy aircraft before they could even make an attack run. The night battle had turned in favor of the Americans, and it was all thanks to the innovation of Albert Nimitz's Miracle Machine. The radar systems, once a mere concept in a Philadelphia workshop, had now proven themselves to be the game changer that the U.S. Navy had desperately needed. This success would mark the beginning of a new era of naval warfare, one where American forces could outmaneuver their enemies under cover of night, a crucial advantage in the Pacific theater. But this was just the beginning. The Miracle Machine would continue to build radar systems faster than ever before, and soon it would be deployed across the entire U.S. Navy, from the largest battleships to the smallest destroyers. Location: Pacific Ocean, 1942. January 15th, 1942. Pacific Ocean. As the U.S. Navy expanded its use of radar technology, the tides of war in the Pacific began to shift. By early 1942, the Japanese fleet was no longer able to strike without fear of being detected by American radar. The advantage of surprise, once their greatest asset, was now gone. The Japanese had underestimated the power of radar, just as they had once underestimated the might of the U.S. Navy itself. In the Battle of the Coral Sea, fought in May 1942, radar played a decisive role in helping the U.S. Navy track and counter Japanese forces. The radar systems built by Nimitz's Miracle Machine were responsible for guiding American aircraft to intercept the enemy before they could reach their targets. The result was a historic victory for the Allies, as the Japanese were forced to turn back, unable to achieve their objective. The success continued at the Battle of Midway in June 1942, where the use of radar helped locate the Japanese fleet and allowed the U.S. Navy to strike decisively, sinking 4 Japanese aircraft carriers. The damage to the Japanese fleet was catastrophic, and it marked the turning point in the Pacific War. Nimitz's Miracle Machine had done what no one could have predicted. It had given the U.S. Navy an unparalleled edge in naval combat, allowing them to fight and win night battles, strike with precision, and stay one step ahead of the Japanese. The machine had transformed naval warfare, giving America the tools it needed to win in the Pacific.